Hello and welcome to Clarkenomics. In this video, we're going to work on calculating price elasticity of demand. But before we can do that, we have to start a little bit simpler. We have to start off by calculating something called percentage change. So here's the formula for that, just to kick things off. First things first, percentage, fine, but that little triangle, if you're not familiar with that Greek letter, that is the Greek letter delta, and it means change. So I'm going to abbreviate percentage change as percentage symbol delta. And here's how you calculate it. You take the new value minus the old value, take the result of that, and then divide it by the old value and multiply it by 100. Now, if none of this is making sense to you so far, that's okay. I just wanted to kick things off with the formula and give you a little tip to remember it. To calculate percentage change, remember no, meaning new minus old divided by old, N-O-O, no. Now, again, let's apply this because it'll make way more sense once you actually see it in action. So, for example, the price of milk goes from $3 a gallon to $5 a gallon. The question one would ask is, how much of a percentage increase is this? And so here's how we would calculate it. We take our new value, which is 5, that's a result of the change, subtract our old value, which is $3, which is what it was before, and then we divide the answer to that by the old value again, which again is $3. So that would look like this. 5 minus 3, new minus old, divided by 3, which is our old, equals 2 over 3. And 2 over 3 is 0.66. Now, to turn that into a percentage, to turn any decimal like that into a percentage, all you have to do is multiply it by 100. And so if you do that, you're going to get an answer of 66%. So that's how you calculate percentage change. So the answer to this question is the price of milk increased by 66%. So that's how you calculate percentage change. And that's going to be very important when it comes to calculating price elasticity of demand. But let's do one more piece of practice before we move on. So let's say that the quantity demanded of notebooks decreases from 800 down to 200. So the first step here is, what's your new value? What's your old value? The new value is 200. Your old value is 800. And so if we plug everything, new minus old divided by old, it would look like this. 200 minus 800 divided by 800. 200 minus 800 is negative 600. Divide that by 800, and you're going to get negative 0.75. Again, we want to turn that into a percentage. So we'll go ahead and multiply negative 0.75 times 100, and that's going to give us negative 75%. So the answer to this question is, the quantity demanded of notebooks decreased by 75%. Now, the one thing you have to be a little careful here with is you have to watch how you phrase things. So you have to avoid double negatives, meaning you wouldn't say that the quantity demanded of notebooks decreased by negative 75%. Because that would mean that the quantity demanded of notebooks actually increased by 75%. So just make sure you're not using a double negative by accident, because that's going to give you a different meaning. All right, now that we've done enough with calculating percentage change, we can apply that to the formula for price elasticity of demand. And once again, I'm just going to throw it at you. Here it is. So you take the percentage change in quantity demanded, and you divide it by the percentage change in price. So, what do all these things mean? Once again, that little triangle shape, that's delta, that means change. QD is quantity demanded, and P means price. So, one thing to consider, when you plug all this in, your answer will always come out as a negative number. Why? Let's think about it. Remember how demand works. When one goes up, the other goes down, right? So if price were to rise, quantity demanded would decrease. If price were to fall, quantity demanded would increase. So one of the two values, whether it's price or quantity, is always going to be negative. Just one though, not both. But one's always going to be negative, meaning that you're going to come out with a negative answer to this. However, when we do price elasticity of demand, we always just take the absolute value, because the negative actually doesn't really matter that much. Just remember, just ditch the negative here, stay positive. All right. Now, again, when we're doing a formula like this, the best way besides explaining it is to actually see it in action. So let's do an example with nothing other than our favorite, widgets. So a word problem involving price elasticity of demand might look like this. Initially, the price of a widget is $200, and at that price, the quantity demanded is 700. When the price of a widget rises to $500, the quantity demanded of widgets falls to $300. That makes sense. Higher price, lower quantity demanded. And from this information, I would say calculate price elasticity of demand. Now, before you get too overwhelmed, one of the best strategies to tackle a question like this is to set up a table with the information. I did this one for you. So you've got your new value, you've got your old value, you've got your quantity demanded and your price row. So your new quantity demanded is 300, your old quantity demanded was 700. Look above at the information, right? It's right there. The new price is 500, the old price was 200. So if you plug all that stuff into a little table, and this takes like 10 seconds to make, then it's going to be much harder to get yourself all mixed up. Pro tip here, make your first row quantity demanded and make your second row price. Because eventually, remember, quantity demanded, the percentage change in that's going to be your numerator, and percentage change in price is going to be your denominator. And it's just better to keep them organized like this because you will be less likely to get it mixed up later. So let's do some calculation. First thing we have to figure out is the percentage change in quantity demanded. New minus old divided by old. It would look like this. 300, your new quantity, minus 700, your old quantity, divided by 700. Remember, order of operations matters here, right? So you have to make sure you do 300, subtract 700 first before you divide by 700, right? Because if you did 700 divided by 700 and subtract that from 300, you'd get 299, and that's very wrong. So order of operations matters if you're typing this into, say, like a graphing calculator. So if you do all this math, you're going to get negative 57.14%. There's our negative number, so we know the other one has to be positive. Then, if we do percentage change in price, that's our new price, 500, minus our old price, 200, divided by our old price, 200. Take all that, multiply it by 100, you get 150. So now when we need to calculate price elasticity of demand, we have the two values that we need. We always take the percentage change in quantity divided by the percentage change in price, Q over P. Just remember, QUIP, QP. Now, if we plug all that stuff in, we'll get negative 57.14 divided by 150, pretty easy stuff, and that comes out to negative 0.38. But if you remember, when we calculate price elasticity of demand, we drop the negative and just make it an absolute value. So the answer to this question would be price elasticity of demand is 0.38. Now, one important thing to remember, direction matters. In other words, if you were to accidentally swap the new and old values and move in the opposite direction, you would actually get a different answer. Because while price elasticity of demand might sound a lot like slope, rise over run, it is not. It's percentage change, which actually affects these calculations tremendously. So make sure you straighten out which is your new value and which is your old value. If you want to get super fancy, you can look up something called the midpoint method, which makes it so that the direction doesn't matter. But as long as you're calculating percentage change like we talked about with new minus old divided by old, the direction of the shift, the change here, matters a lot. So we've got our answer. Let's talk about how to interpret that answer. Like it's 0.38, okay, who cares? What does that even mean? The key number here to compare your answer to is 1. So for instance, if you calculate the price elasticity of demand for a good and your answer comes out to be greater than 1, we would categorize that good with that price change specifically as a price elastic good. What that means is a change in the price changes quantity demanded by a factor of more than 1. So for instance, let's imagine that you came out with an answer of 2, elasticity were equal to 2. If the price increased by 25% for that good, you would see a 50% drop in the quantity demanded. It's a factor of 2. A 25% change in price results in a 50% change in quantity demanded. In the opposite direction though, you have to remember, one goes up, the other goes down. If your answer comes out to be less than 1, we would call that good price inelastic. What that means is a change in the price changes the quantity demanded by a factor of less than 1. So for instance, let's say you did your math and elasticity came out to be 0.5. What that would mean would be a 25% increase in the price of a good would result in a 12.5% drop in the quantity demanded. Do you see how these numbers work, right? A 25% increase results in a decrease of half the percentage. And remember, your answer is going to be coming out to be greater than zero because we always take the absolute value of price elasticity of demand. So it's either going to be greater than 1, less than 1, or equal to 1. And if your elasticity is equal to 1, it's what we call unit elastic. And what this means, if you can maybe predict this, is a change in price changes quantity by a factor of exactly 1. For example, a 25% increase in price will result in a 25% drop in the quantity demanded. It is a proportional change of quantity demanded due to the change in price. So that's how elasticity is calculated. That's how elasticity works. It has all kinds of implications for things like firms calculating their revenue, right? Should we raise the price? Should we not raise the price? Because if a firm raises the price and it's going to result in a huge drop in quantity demanded, they might not want to do that. But if a firm can raise their prices without seeing that big of a decrease in quantity demanded, that might be in their interest to do so. So there's all kinds of practical implications for price elasticity of demand, and now you know how to calculate it. Thanks for watching.